Now, if you want one more example for three-dimensional object, you can select say cone or cylinder, etc. Let us do a cone. Suppose this is a cone of height h. This is a cone of height h. Let us try to find center of mass for the cone. For this, let the apex angle be alpha. Choose an element here of thickness dy. Let at a distance y from the origin. Here also you choose the axis like this. Axis of the cone coincides with y axis and x axis is this one. So, initially only we are making center of mass x coordinate 0, z coordinate 0. Only thing you have to find is y coordinate here also. So, to find the y coordinate here also we will apply the same procedure. The procedure is, first we should find the mass of this element, which is at a distance y from the center, from the origin, and thickness dy. First of all, for this element, mass is equal to area. Area means pi into, suppose if this is r, pi r square into dy. Area of this element is pi r square into thickness is dy. So, volume is this into mass per unit, mass by, suppose mass of the cone is m, or let us take let the density of the cone be rho, then it will be the mass. Volume into density will give you mass. Now, this r can be eliminated in terms of y, because we are integrating in terms of y. Let us try to eliminate the r by taking tan alpha. Tan alpha is equal to r by y. So, r is equal to y tan alpha. Therefore, dm will be equal to pi into r square means y square tan square alpha dy into rho. So, we have the mass of the element chosen here, which is equal to this. Dm we got. Now, what we require is center of mass coordinate. Ycm is equal to 1 by, we can use this relation, integral ydm by integral dm. Limits of y are from 0 to h here. Y is extending from here to here, no? So, 0 to h. So, now let us integrate these two, denominator and numerator. This is equal to y in, y means dm is equal to y into dm means y into dm is pi into y square tan square alpha dy into rho divided by integral of dm means pi by square tan square alpha dy into rho. Rho gets cancelled. Limits are 0 to h, 0 to h. Pi gets cancelled. So, what we are having here is integral tan square alpha gets cancelled because alpha is constant. What is left out is y cube dy divided by integral of y cube dy from 0 to h divided by y square dy from 0 to h. So, this will be equal to y power 4 by 4, limits are 0 to h divided by y cube by 3, 0 to h. So, now this is equal to h power 4 by 4 divided by h cube by 3. H cube and this power 4 gets cancelled. 3h by 4 is the y coordinate center of mass. So, y coordinate of center of mass is equal to 3h by 4. X coordinate and z coordinate are 0. So, for the cone, from the apex, center of mass will be located at x equal to 0, y is equal to 3h by 4, z is equal to 0. This is how we find the center of mass for various objects, 3-dimensional, 2-dimensional, etc. Now, you must not have any doubt in calculating center of mass for any symmetric figures like this. Always steps are very simple. First of all, you choose the axis in such a way that many of the coordinates are eliminated. As we are doing here for cone, hemisphere, etc., x coordinate and z coordinate are simultaneously eliminated. X coordinate is 0, z coordinate is 0, because we are selecting the axis of the object along the y axis. Then your job is only to find the y coordinate by using this relation. YCM is equal to integral y dm by integral dm. Here also, in every case, the first step is finding dm. You have already seen. In all cases, first find dm, then apply the relation. It is very simple thing. So, generally students find it difficult because of unable to choose the element. That is why I have given so many examples. Now, you should be in a good position to do any problem relating to center of mass of extended objects. Now, let us go to further extension of this topic center of mass by studying the motion of center of mass. Let us study motion of center of mass. Already we know that position vector of center of mass is equal to, for number of particles m1, m2, m3, etc., position vector of center of mass is equal to m1 r1 plus m2 r2 and so on by m1 plus m2 and so on. This is the relation for position vector of center of mass. If m1, m2, m3, etc. have position vectors r1, r2, r3, etc. Now, let us differentiate this with respect to time. If you differentiate this with respect to time both sides, what we will have is dr by dt is equal to m1 into dr1 by dt plus m2 into dr2 by dt by m1 plus m2 and so on. Actually, here also you can extend like this. Now, dr by dt is rate of change of position vector of center of mass. Rate of change of position vector of center of mass means velocity of center of mass. Velocity of center of mass is equal to m1 into, this is rate of change of position vector of first particle m1, which is automatically will be v1 plus m2 v2 etc. by m1 plus m2 and so on. So, this equation will give us velocity of center of mass. Velocity of center of mass is equal to m1 v1 plus m2 v2 and so on by m1 plus m2 and so on. Now, if you multiply this equation, if you cross multiply this equation, what you will have is m1 plus m2 etc. into VCM is equal to m1 v1 plus m2 v2 plus etc. So, this is total mass of the body, which is supposed to be the mass of center of mass into velocity of center of mass, means in practical it will become the momentum of the center of mass. So, momentum of center of mass is equal to this, which is equal to sum of the momenta of all the particles of the system. In a system, if there are n particles or any number of particles, momentum of center of mass is equal to sum of the momenta of all the particles in the system. That is the meaning of this. P of center of mass is equal to P1 plus P2 plus P3 etc. Now this is the sum of the momenta of all the particles of the system. This is the momentum of the center of mass. So now relative to the center of mass, what would be the momentum of all the particles? What would be the linear momentum of all the particles of the system with respect to the center of mass? Then in that case, what we will have? This minus this will come. This minus this means actually both are equal, so it would be 0. That means this is the most important point. The sum of the total momentum of a system, with respect to center of mass is 0. The total momentum of a system with respect to center of mass is 0. So relative to center of mass, momentum of a system is also 0. Same thing told in a different way. Now let us choose the same equation. V center of mass is equal to m1 v1 plus m2 v2 and so on by m1 plus m2 plus and so on. Again, let us differentiate this equation with respect to time. dVcm by dt is equal to m1 dv1 by dt plus m2 dv2 by dt and so on by m1 plus m2 plus and so on. Now this is effectively the acceleration of center of mass. So acceleration of center of mass is equal to m1 into, this is acceleration of the first particle a1 plus m2 into, this is acceleration of the second particle a2 and so on by m1 plus m2 plus and so on. So this equation will tell us acceleration of center of mass. Now if you cross multiply this equation again, you will get like this, m1 plus m2 and so on into acceleration of center of mass is equal to m1 a1 plus m2 a2 plus and so on. So here this is the total mass, which is supposed to be the mass of center of mass. Mass of center of mass into acceleration of center of mass means force acting on the center of mass. So force acting on center of mass is equal to force acting on the first particle plus force acting on the second particle and so on. So force on the center of mass is sum of the forces acting on all the particles. Sum of the forces acting on all the particles is equal to force on the center of mass. Suppose if you take a system of particles, if there are no external forces on the system of particles, if there are only internal forces, suppose if they are colliding with each other like that, suppose if there are particles like this, if they collide with each other, then what happens by Newton's third law, each will exert opposite forces on each other. Suppose if this will exert force F1 on this will exert force minus F1 on this, like that internal forces cancel each other. So net sum of forces will be 0 when external forces are not acting on the individual particles. Automatically center of mass will have 0 force. What I am trying to tell is, if on a system there are no external forces, internal forces cannot create any resultant force. Therefore, net force on the system is 0. Automatically, force on center of mass is also 0. So, that is regarding the force acting on the center of mass. We will conclude this topic motion of center of mass tomorrow, and then we will do some examples relating to motion of center of mass. So we will meet tomorrow.